Greetings. I have a lovely question for you. It's number 18. It is off of your Newton homework, and this one's a tough one. This one really makes us think. It tests our ability to do something that involves friction. Now, we still see the coefficient of friction is 0.350. So that's our clue. That's our huge clue that it involves friction. So as soon as it involves friction, we should be thinking, all right, well, here's my equation. FF equals mu times Fn. And we know mu, apparently, because if we look on here, I'm going to highlight mu here. And then, well, here's mu right here, right? There's our coefficient of friction. So mu is given. Now, what are we really looking for, I suppose? What force must be exerted to move the box at a constant speed? What makes this one so hard is it's looking for the force here. It's looking for this. And this x is the force on an angle, not the components, but the angle. And so that makes us, well, have to think a little bit more sophisticatedly because now we can still make a nice right triangle out of this. And we're pulling, so we have a vector in this direction, and we have a vector in this direction. And so I'm creating a right triangle. And we also have a mass, and we want to deal with normal forces, and we're on a level surface. So we're still going to have to do something with the weight as well. And so I'm going to say, well, let's find the weight to start off. I will say Fw equals mg, and the mass is 5 kilograms times 9.8. And I multiply that out, and I end up with the value of 4.9. Now that 4.9 newtons will pull straight down. This is going down this way. And that is perpendicular. So that's perpendicular to what's going on, 4.9 newtons. And that's going to be more or less our normal. However, we happen to have two separate vectors going on in that dimension, which we might call the y dimension. So we have 4.9 newtons in that direction, and then we also have another dimension going on here, which is the component of Fn. And this is going to be right in the same vein as any other question we did involving a level surface and friction. Therefore, the adjacent leg of this triangle I've drawn is our FF. Well, now let's focus on our normal to start off. Our normal is perpendicular. 4.9 is the weight. However, we have to worry about this component of Fn as well. And if we look at these two arrows, they're opposite one another. And so I could draw these two arrows, well, opposite each other perhaps. If I wanted to draw them, I don't know, like so, I could make one arrow go down and another one is going in the opposite direction, starting at the same origin, and then I have another arrow going in the opposite direction, right? And so one of these two is my 4.9. So here we are at 4.9. Then I have another one going in the opposite direction, which is affiliated with the component of Fn. And so this component of Fn, which is here, in fact, needs to be taken away from the 4.9, which is the weight. We take it away because it's going in the opposite direction. Well, if we wanted to find this component of Fn, we'd have to do some trigonometry. And the angle that we're working with is 25 degrees. Now, if we knew x, we would have opposite over hypotenuse, which is sine. And so this component of Fn is, well, the sine of 25 degrees times whatever the hypotenuse would be, which we're deeming x. And so what is this but 4.9 minus the sine of 25 degrees times x? Now we can think in a similar vein for the force of friction, whereas we can't in fact solve the force of friction outright because we don't know what x is, and x is the hypotenuse. So what we're going to call the force of friction is, well, the cosine of 25 degrees times x. Enter friction equation. Remember our friction equations here. Here's our friction equation. Now I'm going to use this thing because I have a representation of every variable in it. Because what I can do here now is say, well, what is FF? I'm going to rewrite it over here. My FF equals my mu times my Fn. And what is FF but the cosine of 25 times x? And that equals mu. We're given mu. That's 0.350. Times whatever the normal is. Now the normal is this somewhat complex thing because the normal is the weight, which is 4.9 newtons, minus whatever this component of Fn is, which is the sine of 25 times x. Now we have an equation with a single variable. Realize the cosine of 25 and the sine of 25 are just decimals you can acquire from your calculator. You distribute your 3.50 times the two separate terms. One is an x, one is a non-x. Consolidate like terms, and you can make your way down to a final x. And if you do this appropriately, you absolutely should get a final x of 16.3 newtons. If you find that difficult, play some games with your algebra. You're still having a hard time? See me.